Hi everyone, welcome to Mernda Central Science Labs. I'm Marcus.
And I'm Betty.
And we're your
Lab
techs. Today's topic is chemical reactions. And you might think, well, why are chemical reactions important to us? Well, chemical reactions actually make the entire world around us work. Whether it be from living things like us, where chemical reactions make all our body processes work, and our digestion, and our brain function, and everything else about us, or whether it be things that we eat, chemical reactions are all involved in the actual process of growing fruit and food and that sort of thing, or whether it be everyday items that we use around the house, chemical reactions are involved in actually getting the things that we dig out of the ground or things that we grow and turning them into things that we can use. The purpose of our experiment today is to observe 4 different chemical reactions so we can see chemical change in action. The first will be a colour change reaction where we're going to look at our indicator paper and how it changes colour with addition of an acid. The second one is going to be an acid-metal reaction where we're going to see what happens when we add acid to metal, what the product's formed and how we can observe a chemical reaction is taking place. Then we're going to look at a precipitation reaction. Precipitation reactions are where you add 2 solutions together and they form a solid. And we're going to make some observations about how we know a solid's being formed. And the last one is acid-base reaction or a neutralization reaction where you add an acid to a base and it actually forms water and a salt. What materials do we need for our experiment today? Well, firstly, of course, safety equipment as always, gloves, because we're going to be handling acids, safety glasses, because we don't want to get acids into our eyes, which are obviously quite bad for our eyes, and a lab coat to protect our clothing. So the equipment we need for today is going to be a test tube rack. We're going to need 4 test tubes to actually do our chemical reactions in so you can observe the chemical reactions and how they look. We're going to need some chemicals and some test paper. So the first thing is going to be some universal indicator paper, which is going to be used instead of the litmus paper that you might have used originally to observe a colour change. We're going to need some magnesium ribbon. Now magnesium ribbon is just a magnesium metal, so we're going to react that with an acid. So obviously we're going to need some hydrochloric acid. Hydrochloric acid is going to be used in a couple of our other experiments or other reactions as well. We're going to need some silver nitrate, which will create a precipitation reaction with the hydrochloric acid. And we're going to need sodium hydroxide to do a neutralization reaction with the hydrochloric acid. Alright, so our first experiment or our first chemical reaction will be with universal indicator paper. Now if you can zoom in on that, now our solution is going to be quite acid, so the universal indicator paper is going to turn a dark orange colour. Well, that's what we hope at least, so we'll see how we go. We'll tear off a strip and we'll put it into our test tube. Drop it into the test tube. We'll get some 2 molar hydrochloric acid. Now 2 molar simply means how strong the acid is. It means it has 2 moles, which is a bit complicated, but it means a certain number of atoms in each litre of solution. If we pour it in there, we'll see the colour change turns to a dark orange very, very quickly. The second reaction we're going to look at today is an acid-metal reaction. Now we're going to use magnesium ribbon, which is just little pieces of magnesium ribbon that have been cut up that we're going to put into our test tube. And we're going to add 2 molar hydrochloric acid again, and we're going to observe what happens. Now you might actually be able to see that even there, it's bubbling away madly, which suggests that there's a gas forming. So there's 3 ways you can actually test for the gas. You can look for the bubbles. You can actually waft it towards you. You've got to be very careful. You don't know if the gas is toxic or not. So you've got to be very careful about how you smell gases and see if you can smell something different coming out of the tube. That's another sign of gas being formed. So another way we can test for gas being formed with an acid-metal reaction is, because acid-metal reactions often form a flammable gas, is to do the pop test. So what we'll do, we'll get our magnesium ribbon in the tube. We shall add some hydrochloric acid. We will get a match, light the match, and we'll hold the match up to the tube, and hopefully you get a bit of a pop. And that's a little bit of flame shooting out of the tube, and that bit of a pop tells you that there's a gas being formed from that reaction. Alright, so if we look at our acid-metal reaction as a formula on the board, you might be able to see how the chemicals actually change positions. So hydrogen chloride, which is hydrochloric acid in fact, plus the magnesium ribbon, which is the metal, forms a new salt called magnesium chloride. Now you might notice that the magnesium and the chloride are grouped together now. And what's left over here is hydrogen, which forms hydrogen gas. If we look at that as chemical formulas now, we'd write hydrogen chloride as HCl plus magnesium, which is just called Mg as a chemical formula, and that will go to MgCl2 plus H2. So the chemical reaction as a formula here, we've got hydrogen chloride, hydrogen and chlorine plus magnesium. The chlorine goes over with the magnesium over here to form magnesium chloride, which is a salt, and the leftover hydrogen combines to form hydrogen gas. Okay, our third reaction for today is going to be a precipitation reaction. And we talked about precipitation reactions in the introduction in that they take two liquids which form a solid which doesn't dissolve in the liquid anymore. So we're going to use hydrochloric acid. We're going to put some hydrochloric acid into the test tube first. That'd be good if it was open. Hydrochloric acid into the test tube first. We've got a nice bit of hydrochloric acid in there. We're then going to take some silver nitrate. So we've got silver nitrate there. And silver nitrate is a salt which contains silver and obviously nitrogen and oxygen. And we put it in there, you immediately see a reaction occurring. Before you could see that through that tube, now you can't. And that's because there's a solid forming in the tube. Right, for our third experiment we did hydrogen chloride, which is hydrochloric acid, and we mixed it with silver nitrate. And when we mixed those two together we ended up with silver chloride, which is actually white. And the leftovers, so the silver and the chloride combine together to give us silver chloride, and the hydrogen and the nitrate, hydrogen and nitrate together gives you nitric acid, so produce nitric acid as the end product. So if we look at that as in chemical formula terms, we've got hydrogen chloride, which is hydrochloric acid, HCl, plus silver nitrate, Ag, which is silver, NO3, which is nitrate, gives us silver chloride, so AgCl plus HNO3. So if we look at that carefully, you can see that the chlorine and the silver have come together over as silver chloride. The hydrogen and the nitrate have come together as nitric acid. And the important part to remember is that this silver chloride can't dissolve in water, so when you add these two together, which are clear liquids, all of a sudden the liquid turns white because it can't dissolve in water anymore. Right, and for our fourth experiment we're going to do a acid-base reaction. And acid-base reactions can be observed in lots of different ways, and one of the classic ways is actually to get a temperature change or an energy release, so you get the temperature going up or down. Alright, so we're going to do our acid-base reaction here in front of the black paper so you can see it. We're going to add hydrochloric acid to the test tube. We'll add a fair bit so we can get a reasonably accurate measure of how much energy is in the system. And I hope you can see what the temperature is there. It says it's about 23 degrees or something like that. Now if we get our sodium hydroxide, which is quite strong sodium hydroxide, acid-base reactions create what they call an exothermic reaction. An exothermic reaction releases heat. So we'll add the sodium hydroxide, and if you look at the thermometer you can see the temperature rising quite dramatically. It's now approaching about 40 degrees, so if we give it a bit more of a stir we might get a bit more. So yeah, about 40 degrees it's gone up to. So it shows that a chemical reaction has taken place and that we've got sodium chloride or salt forming plus water with the release of heat. So we had hydrogen chloride, hydrochloric acid, plus sodium hydroxide, which is the base, and you ended up with sodium chloride and water. And again, if you look carefully, the chloride and the sodium of the two different chemicals have joined together to form sodium chloride, which is just common salt. And the hydroxide, which is OH, and the hydrogen over here have combined to form water. So looking at that reaction as chemical formulas, again, hydrochloric acid is HCl, hydrogen and chlorine, plus sodium hydroxide, which is Na for sodium, and OH for hydroxide. And if we go across to here, we've got sodium again, so Na for sodium, Cl for chlorine, and we've got water, which everyone knows is H2O. So if we look really carefully, again, the chlorine and the sodium over here have joined together to form the new compound sodium chloride, and the hydrogen and the OH, so two hydrogens plus an oxygen, gives us H2O, it's just water. So what have we learnt from today's experiment? Well, we've learnt that all chemicals are made up of atoms and they can group together to form larger particles called molecules, and that different molecules or atoms can actually react together to form new substances, and that's very important for life and for all the things we surround ourselves with in everyday life. Now, our experiments, we did a colour change reaction to start off with, where we added a yellow indicator paper, universal indicator paper, to acid, and we observed a colour change, and that's for you guys to put into your tables and to record and to talk about. We then did a acid metal reaction where we had a gas being formed, and the gas could be observed by the bubbles forming, by the smell of the gas, and also by something called a pop test, which tests for a flammable gas. We then had a precipitation reaction, and the precipitation reaction formed solid. Now, when we first did the reaction, it was actually turned pure white, but you can see now that solid has actually dropped to the bottom of the test tube, and we've got little pieces of solid in there. And the last one was a neutralization reaction, or an acid-base reaction, where we added acid to base, and we observed a temperature change or an energy release, so you get the temperature going up or down. That's what we call an exothermic reaction. An exothermic reaction shows that the chemicals have reacted. In this case, it's reacting to form salt, sodium chloride, and water. Alright, so that's our experiment for today. I hope you've learned something a little bit about chemical reactions and the different sorts of chemical reactions, and hopefully sometime soon you'll be back in the lab for yourselves doing these sorts of experiments and seeing these observations firsthand. Alright guys, that's it from Mernda Central Science Labs for now. Bye from me, Marcus.
And bye from me, Betty.